All right, so I want to go through some of these answers for the unit circle problems that were given to you. So if we go to, I'm going to go to this third page here where it says just to use the unit circle to solve each trig expression. Right, so the process that you're going to go through, let's kind of review that. So if I was asked, what is the sine of pi over 6? Right, so if I have pi over 6 or 30 degrees, what's the opposite over hypotenuse? What is that ratio? Okay, without using a calculator, right, we're just going to give an exact answer without just punching it into our calculator. Well, so we're going to first draw that out. We're going to say, all right, kind of sketch out a unit circle and say, where is pi over 6? That's step one. Pi over 6, like right there, right? And secondly, what is the terminal point that pi over 6 produces? Well, it's right here. That's going to be root 3 over 2, comma, 1/2. Right? So since the sine of any angle is always the y value, if we're utilizing the unit circle, then we're good, because we could look at this point and just say, well, there's the y value. Y value is 1/2, so therefore the answer to this is just 1/2. That is the opposite to hypotenuse is always going to be 1/2. So answer is 1/2 here. Right? So if we just go through, let's just do a bunch of these here. If I said cosine of 3 pi over 2, again, I'm going to sketch that. Where is 3 pi over 2? And well, 3 pi over 2 is down here, right? What's the point that would cross the unit circle for 3 pi over 2? That would be 0, -1. The cosine is always the x value of the point on a unit circle. So in that case, the answer is 0. So now we have 0 here. Let's talk about the tangent. So looking at this tangent of 5 pi over 6. All right, so tangent 5 pi over 6. All right, so we're going to sketch the angle. Where is 5 pi over 6, right? That's going to be over here. So eventually, if we kind of understand where all the angles are on the unit circle, and we kind of have, what the points will be, okay, we want to be able to just have this memorized or be able to figure out the terminal point without always taking out, a unit circle sheet and just like looking it up and saying, all right, here it is, right? We want to be able to draw this 5 pi over 6, sketch it, and then kind of reason and say, all right, what's this point? Well, that's going to be a long side to the left. It's going to be -root 3 over 2 and comma, it's going to go up 1/2. So there's the point. So there's the point for 5 pi over 6. Now the tangent, we have to remember, the tangent is y divided by x. So the tangent of 5 pi over 6 is going to be whatever the y value is divided by the x value. So unfortunately, with the unit circle, we have fractions. So when we have to divide, like in tangent, we're going to be dividing fractions. And so we have the y value, which is 1/2 divided by -root 3 over 2. And we have to just clean this problem up. So we have to say, well, division is multiplication of the reciprocal. So this is actually 1/2 times 2 over root 3. And if we multiply those together, these 2's would cancel off, and I would get -1 over root 3. And if we clean that up and we get rid of the square root on the bottom, then we'd have -root 3 divided by 3. So there's our answer for number 3. All right, so number 4. Okay, so these are kind of those problems where they're not directly on the unit circle, but you have to be able to reason and figure out where is, for example, -4 pi over 3 on the unit circle. So, all right, so now I have -4 pi over 3. Well, I'm still going to draw it. And so again, what we can do is we can reason, you know, in this problem, we know that 4/3 pi would be like going around and being down here, okay? So some people will look at that and say, well, I'm just going to go the negative direction. I'm just going to rotate this way, half pi, full pi, and 4/3 pi is going to be like right here, okay? If you don't want to do it that way, remember we can find coterminal angles with that. So negative 4/3 pi, if we're unsure where that is on the unit circle, we can just take negative 4/3 and we can add or subtract 2 pi to that to get something coterminal. So in this case, I'm going to add 2 pi. Add 2 pi here, or in this case, since we need common denominators, that would be 6/3. So that'd be 6 pi over 3. And so if I add 2 pi, I get 2 pi over 3. Well, you can see that when we drew this out, this is 2 pi over 3. It hasn't changed anything. That's still the location, right? So that's 2 pi over 3. Negative 4/3 pi would just be the rotation this way, but it doesn't really matter how we got there. The point is that we got to the correct direction, okay? And so then we think about, same as before, what's the point on the unit circle? In this case, the point is negative 1/2, comma, root 3 over 2. All right, so since the cosine is the x value of the point, again, piece of cake. This is just going to be the x value, which is negative 1/2. Okay, so hopefully you're kind of picking up on the workflow of how to solve problems with the unit circle. Again, every single time here I try to sketch out the angle and figure out the point, right, the terminal point, and then use the unit circle definitions to work through your answer. Sometimes that's easy as just saying the x or the y, and sometimes we have to divide. So let's drop down here. Let's actually go maybe to the back and do a couple of these on the back side. So let's look at number 8, right? Cosecant to negative 9/2 pi. So if we were doing that one, right, we would say, all right, well, where in the world is negative 9/2 pi? Okay, so there is, of course, always multiple ways to think about it. I could say, all right, negative 9/2 would be going this way, and man, you could count off by halves, right? This is 1/2, 2, 3, 4, 5, 6, 7, 8, 9. 9/2 is, I think, going to be just pointing straight down, right? You could also think about that as a mixed number, negative 4.5. So negative 2 pi, negative 4 pi and a half. It's down here, okay? If you want to go the coterminal route, as discussed before, you could say, well, I only like doing it like this, so negative 9/2, I need to find an angle that is on the unit circle that I have sort of memorized and traditionally on there. Well, then let's just keep adding 2 pi to this. So negative 9/2, I could say plus 2 pi, so or plus 4/2 pi, right? Common denominators. So that would give me negative 5 pi over 2. And then if you're taking it like this and saying, well, that's still not, in my mind, that's not on the unit circle because it's negative. Well, in reality, it is on the unit circle, but you know what I mean. We could just do it again, right? Let's add another 2 pi. So plus 4 pi over 2. All right, well, that's negative 1 pi over 2. And hopefully at that point you could say, yeah, I'm just going to go down and it's going to be pointing straight down. But if you really wanted to keep going, you could say, well, 4 pi over 2, let's add 2 pi again. Okay, then this is 3 pi over 2. And then you could say, 3 pi over 2, I remember that's just straight down. Okay, so you obviously don't have to do that, but just, again, remembering that this right here is coterminal with this, which is coterminal with this, and it's coterminal with this. All these angles are pointing down. And however you can figure out where negative 9/2 pi is, where it's located and where it's drawn is fine. We just have to make sure we draw it accurately and we have it in the right spot. Okay, so it's pointing straight down, therefore it has a point of 0, -1. And then we think about cosecant. Cosecant is 1 over the y value. It's the reciprocal, right? This is the reciprocal of the y value. Well, if you look, the y value is -1 right here. The reciprocal of -1 over 1 would just be the same thing. It would be -1, right? So our answer here would just be -1. Okay. All right, let's just do a couple more. All right, so looking at number 9, 7/4 pi. Where is that on the unit circle? 7/4 is going to be from here. 1, 2, 3, 4, 5, 6. 7/4 is over here. That point is going to be √2/2 and -√2/2. And I know that the secant is 1 over the cosine. It's 1 over x. Right? So if I look at the x, it's √2/2. The 1 over that, or the reciprocal of that, is going to be 2 over √2. And I'm going to clean that up by multiplying by the square root of 2 on top and bottom to get 2 √2/2. And then, yes, these 2's do cancel. Okay, the integer 2 divided by that integer 2 cancels to 1, divides to 1, and we're left with just the square root of 2 as an exact answer. All right, let's look at one more here. Let's say the cosecant, number 10, the cosecant of 7/3 pi. Well, off the top of my head, I know that 7/3 pi is not traditionally labeled on a unit circle, but it is coterminal with 1, right? So again, this is one where we have to figure out where is 7/3 pi on the unit circle. Okay, so let's just go with the coterminal route here. 7/3 is coterminal with, I'm going to subtract 2 pi, so that's, I'm going to subtract 6/3 pi to get a common denominator, and that is going to give me pi over 3. All right, I know where that one is, right? So pi over 3 is just up here, quadrant 1. Now I'm going to have my point. The point is 1/2 to the right, a short side to the right, and then the long side is the y value, so √3/2. All right, I have my point. The cosecant is 1 over the y value, or it's the reciprocal of the y value, the reciprocal of sine. So if we look at the y value, it's √3/2. There's √3/2. Cosecant is the reciprocal of that, so 2 over √3. So similar to the last one, we're going to get rid of this square root of 3 on the bottom. So our answer would be 2 √3/3. 2 √3/3. And we would just keep on doing those types of problems. So hopefully that gives you, if you were struggling on these types of problems, hopefully that gives you kind of the steps that you need to be taking and the thought process you need to be taking as you think through these problems and solve them. Okay. Ideally, you're using the unit, you're not just taking a pre-made unit circle and just looking things up, but hopefully you're getting better at understanding the patterns, understanding how to draw the angle and locate it efficiently, and then thinking about getting that terminal point, right, without always looking it up. You want to have that memorized or be able to think through to get the point. Okay.